Welcome, friends. So, today we are going to discuss heartbeats. So, I already made it done. So, if you are new, this is a high level design series. So, you can go through all these in my YouTube channel as well. Or if you go with this system design, HLD building blocks, so you will see all the notes here in building blocks. And if you go at the front, you will go other uh, nodes, and now we are at building blocks. So these are our key concepts. We discussed everything. Now building blocks we are discussing. After that, we're gonna have trade-off. Then we have architectural, and then we will start low level design as well. Okay. So right now we are at here heartbeats. So it's a very important concept, simple but important. So I already prepared some notes as well for you. So let's start it. So heartbeats. Hence distributed systems. So what is heartbeat? So imagine you are managing a huge office. Okay, huge office building with hundred of employees working in different rooms. Every seconds, every 5 seconds, each employee sends a small message to the security desk. I am working. Okay, if employee suddenly stops responding, security assumes employee may be sick, room contains broken, something has gone wrong. Okay, that tiny I'm alive signal is called heartbeat in distributed system. Okay, so very important, right? In our cluster, we have multiple servers. Okay, and every cluster is suppose we have load balancer, we have API service, whatever, right? We are using API gateway, whatever you are using. So server one, server two, server three, server four, server five, server six. One, two. Okay. So suppose every service sending message to kind of hardware sending to load balancer, kind of, right? So it server about to say yes, I'm alive, I'm working. Suppose server 5 is off, it doesn't sense. Suppose every 5 minutes we have third time set. Okay, so 15 is our 15 second. Suppose 15 second is our timeout. 5 second is our sending heartbeat. No, one time no. After 5 seconds, again no. After 5 seconds, again no. What does that mean? Server 5 is dead. So after three retries or like whatever we set, so after that we assume server 5 is dead. So traffic will not gonna send to server 5, or we'll do like whatever we need to, right? So this is a very simple concept but very important. Okay. Now what is heartbeat? It's a periodic signal sent between system servicing machines to verify what to verify. Company is alive, reachable, healthy, and functional properly. It is one of most fundamental concept in distributed system. Simple but fundamental concept. Okay, important concept. Without heartbeat, server crashes, failed. Whether we will not gonna know. Okay, crashes, network errors, frozen, or node should receive a traffic or not. Okay, simple definition. Heartbeat is a lightweight recurring message exchange between component to detect failure and component and monitor availability. Okay, simple. Real life analogy, just like as I was in hospital, ECG machines. Okay, regular pulse, patient alive, no pulse, emergency. Same in this system, server continuously pulse to each other. Okay, impulse stops, alert triggers, traffic reroutes, backup activates. So now, why heartbeat matters? Modern system contains microservices, database, broker, nodes, everything, right? If failure happen, failure happen constantly without heartbeat mechanism, failure remain undetected. Request keep going to that server, meaning money wasted, time wasted. System become inconsistent. Okay, heartbeat helps him become system, fault tolerance, self-healing, high availability. We already discussed, right? So purpose of heartbeat, we already discussed. This is a kind of purpose, but still in detail. Failure, direction, health monitoring, leader election. So leader election, very, very important concepts in our server side, database side. Okay, we have node 1, node 2, node 3, leader node. Okay, if something is this is not working, node 1 or any node will become leader. Same as here. Okay, client, sorry, leader, replicas. Okay, if leader is not working, then replica will become leader. Okay, so how to know it's not working or went wrong something? With the help of heartbeat only. Okay, so back to the concept. Cluster membership, load balancing, replica monitoring, auto recovery. Now, basic heartbeat, flow by step flow. Okay, first of all, service registers itself, just like as service started. Okay, sends heartbeat periodically. Second step is send service periodically. Then third step is monitor system, track it. Monitoring system, track it. Server send it, now monitoring system, track it. Okay, heartbeats stop. If no heartbeat arrives within time, no heartbeat for 30 seconds, system assume failure. Okay, then recovery action happens. So five step, service register, send heartbeats periodically, monitoring system tracks it. If heartbeat stops, then recovery action happens. Okay, so heartbeat architecture we already discussed. Okay, I draw one diagram. It's the same one. Okay, so this is a leader, server leader. We have four nodes, one, two, three, four. Suppose server 4 is not responding, then we can mark it as server 4 is not working. So we will mark it as failed or dead node. Okay. Now, types of heartbeats. Active heartbeat. Type of heartbeat, active heartbeat. One component actively sends ping messages. Example, master worker. Master will ask worker, are you still alive? Yes, I'm still alive. Okay. Passive heartbeat. Worker will send message to master, I'm alive. Okay, it's like a Kafka, Kubernetes, just like as here, we have consumers. In Kafka, we have consumers, and consumer sends message to broker, like Kafka. Okay, Kafka broker, that I am alive. Okay, so this is a passive heartbeat. Push heartbeat. Sender pushes help into info periodically. Node coordinator. Okay, just like as we discussed. Okay, this is a orchestrator. We have three nodes, node 1, node 2, node 3. So node will send message to orchestrator. I'm alive, I'm alive. Okay? It's the push heartbeat. Now pull heartbeat. Monitor pull status from nodes. Like the same thing. Orchestrator will ask, node, are you alive? Node, are you alive? This is the pull heartbeat. Now, heartbeat timeout. Heartbeat system rely on timeout threshold. Heartbeat every 15 second, timeout 5 second, timeout 15 seconds. If three heartbeats are missed, nodes are dead. Okay. Now, important trade-off. Short timeout. Important trade-off. Meaning, what if, what will Heartbeat gonna do? If short timeout, faster failure detection, disadvantage false alarm during temporary network delays. Long timeout, fewer fast positives, fewer false positives. Okay, slower recovery is classic distribution. This is a classic distribution system trade-off. Okay, usually we go with this. Okay, fewer because fewer false positives. Here in short, we might have some delay as well. So it says okay, not working, something like that. So short is not good. Long timeout is long trade-off is good. Okay, heartbeat in microservice. In microservice architecture, each service periodically reports status, memory, CPU, health. This is the this we generally generally we work in microservice architecture, right? So this is a live thing. Every every some so you will see, right? So our DevOps team uh, like already maintain these things. Every product seconds we get status, memory, CPU usage, health. Okay. So service discovery tool uses Heartbeat to know active instances. Right, just like as in Oreka. We have three services, right? We register our service with Eureka. Suppose we have three services, we register. Okay. So it will check S1 alive, alive, alive. If no health, no heartbeat, it means S1 is dead. It will get unregistered. Okay. Now, okay. So here we have example as well, the same Netflix Eureka, but whatever I discussed uses heartbeat renewal, service flow. What is the flow? The first thing is service registers. Just like as three services, send heartbeats every 30 seconds. What I explained before. Eureka renews lease. Missing hardware means instance removed. Whatever I did here, right? So this prevent traffic from reaching that services. Okay. Now, heartbeat in Kafka. I already gave some idea, right? So in Kafka, consumer sends heartbeat to the consumer group coordinator. Okay. So I Kafka, I can say broker. Okay. So we have here consumer group. In consumer group, we have consumers C1, C2, C3, C4. Okay. So these consumers send heartbeat to Kafka group. If suppose consumer 3 doesn't send, it means it is not working. So these will get re-triggered, meaning reassigned the partitions. Okay. Okay. Uh, Proof consumer is alive, maintain partition ownership. If heartbeat stop, partition rebalance. Another consumer takes over. Okay. Whatever the partition, suppose it has partition 3, meaning sorry 2, partition 0, partition 1, partition 2, partition 3. If this is not working, then it will get distributed. Might be P2 will go to consumer 2. Okay, something like that. So this is a critical for fault tolerance. Here you can see consumer is sending heartbeat, heartbeat, heartbeat. Okay, to coordinator. So consumer sends heartbeat to broker, consumer sends heartbeat to consumer coordinator as well. Okay, acting broker. I already explained. Okay, if something is gone, if something is not working, meaning where the cursor is, suppose this is gone out, so only two will be there, and data will sorry partition will get distributed between two only. Now heartbeat in. Kubernetes, same, whatever we discussed. Send heartbeats to control panel, control panel. If node heartbeat stops, node mark not ready, ports rescheduled elsewhere. Okay. Kubernetes uses kubelet, heartbeat, node status, updates, lease object. Okay. So you know, right? In our cluster, we have multiple ports P1, P2, P3, P4. This is the purpose why we create for production. Specifically, we have multiple nodes, multiple ports, just like as 4, 5 ports, right? Suppose one goes down, three will be alive, even alive. Okay, to distribute the traffic. Now, heartbeats in databases. I think I already gave some highlights, right? Distributed databases uses heartbeats for replica monitoring, primary selection, failover detection. Okay. Now, leader election and heartbeats, simple. One node may become leader when leader consistent heartbeats. Leader alive, followers monitor them. If heartbeat disappear, followers start election, new leader selected. Okay. So this is for just low lights, heartbeats versus health check. Many beginners confuse these. Heartbeat, health check. So two things. Okay. Heartbeat is different, health check is different. Okay, heartbeats like I'm alive. Health check, I'm functionally correct. I'm functioning correctly. Lightweight, more detailed. Frequent, less frequent. Simple signal, deep diagnostic. Okay, heartbeat or health check. Now, example, heartbeat is service is running. Okay, health check is database connected. Cache healthy. Okay, now common heartbeat problems. False positives, whatever we discussed before. Network delay may causes missed heartbeats. System incorrectly marked node as dead. Okay, so that's why we use this long time trade-offs, if you remember. Okay, not short time trade-off. Split brains. Two nodes thinks one is dead, other is dead. Both become leader. Dangerous in distributed system. Network partitioning. Network breaks, but not still alive. Okay, heartbeat cannot reach coordinator. This is a major system distributed system challenge. Okay, so these are our common problems. False positive, fill brain, or network partitioning. Heartbeat optimization technique. So how we can optimize to refrain these failures, not this one, to refrain these problems. Okay, so we have GOSI protocol, we have adaptive heartbeats, we have Firewall failure director. So gossip protocol, instead of centralized heartbeat, node gossip for health information. Adaptive means heartbeat frequency changes dynamically based on load, latency, failures. Advanced failure detection algorithm. Instead of fixed timeout, calculates probability of failure statically. Okay, very very important. I have say. Mm, rest is example. You can go to the notes. Not important. Just a last example. In distributed systems, silence is dangerous. Heartbeats are tiny signals that tell entire system everything is still alive. Okay. So this is our heartbeats. Okay. Why I skip? This is also a examples, not much important. Okay, this example like where we use these, and we already discussed this thing. I put just for sake of notes only. Okay. So this is the heartbeat concept. So I'm wrapping up now. If you have any questions, then comment it out, and we'll meet soon with our next concept, circuit breaker. It is very important in Microservices. Okay. So for now, uh, goodbye. And in case of an issue, just comment me. And if you're new, then subscribe this channel. This will help you because we're gonna have a lot of other concepts as well. This will help you boost your whether you're preparing for your interviews or you're upgrading your concepts. It's very important series. So subscribe the channel. Be with me. Okay. Bye for now.